Okay, take two. Hello, Austin Canoyer.
Oh, code
word is railgun.
He knows about it. He knows.
Does he? No.
Okay, vectors are equal if and only if they have the same length and direction. Okay, now it says same slope, but they have to be pointed in the same direction as well. Two vectors could have the same slope but be pointing in opposite directions. Do you see what I mean?
Yeah.
Okay.
Can they have the same direction and not have the same slope though?
No.
It's like our squares, rectangles.
What's that called?
A vector is in standard position if the initial point is at the origin. So that's where we like to picture vectors, is when they are at the origin. Okay. There are two different types of ways to express vectors. The first one we will talk about is component form, where we write it with the chevrons. Okay, so it kind of looks like an ordered pair, but with the chevrons instead of round parentheses. And remember, to actually find the vector, we would have to take terminal point minus initial point. So V1, that's your horizontal component, V2, that's your vertical component. So yes, we still think of it the same, or we still like, you know, X comma Y, right? But now it's horizontal comma vertical. Okay. Okay, and then the magnitude of a vector. What?
Fire truck. Ambulance.
Like in our parking lot?
Yeah. It's been here for a long time. I think it's a show and tell thing.
Oh, okay. Show and tell. Did you just call it show and tell?
Yeah.
Okay. The magnitude is essentially the length. Well, not essentially. It is the length. And since our vertical and horizontal components will form a right triangle with the vector, then we can use the Pythagorean theorem to find the magnitude. You don't need to write this sentence down because it appeared twice on this page. Sorry. I do that all the time.
We should say the code word like a base with this line.
Well, we were like 5 seconds in when you said the code word.
Sure, we probably heard that.
Yeah.
Railgun.
No, he needs to know how many times we
They're really
say
not
it.
that bad.
Railguns aren't bad at all. It's
We
science.
will talk about them later.
Okay, we're talking
Yes.
The recording isn't on.
Uh,
Can we designate the last 4 minutes for railguns?
Is this on the record?
Terminal point minus initial point of like the y's and the x's for each separate thing, or is it just
Yes.
points?
It'll be like, here, let me show you.
Oh.
Okay, so here I have PQ. It begins at -3,4, it ends at -5,2. So if we take terminal minus initial, we take -5 minus -3, and 2 minus 4 to get our component form of -2. Okay, and then in standard position, that would be vector V. Does that make sense? Okay. Okay, now if we wanted to find the magnitude, the magnitude of V would be 2 square root of 2.
That's all we're doing today.
Not really. But good try.
No, we're doing waking with vector. makes sense. It's hard to read.
I think it's working.
Working.
But it looks like waking.
The R didn't get very curvy. Okay.
Plays forever to something.
Yeah, I don't think Isaac voted my correction.
Oh, I saw it. I saw it. What
Okay.
did it say at first? Remember?
When we add vectors together, we can simply just add the components together. And I want to show you a picture illustrating how we do that. Here is vector u. We want to add to it vector v. And so what we can do is we can draw vector u. From where it ends, we draw vector v. And then we can connect the two for u plus v.
Maybe I'll understand physics afterwards.
Physics 1.
Yep. Or we have to do like the trig ones and last. I did this one.
In the same manner, we can do the same thing with the subtraction of vectors. Now, if I wanted to draw this same picture for the subtraction of u and v, I don't have purple, but here would be u. We would subtract v by just drawing it in the opposite direction. And so then u minus v would look like that.
Okay, so is this just like a one-row matrix?
No.
Yeah. I don't
It's
know.
like a 3-round.
I mean,
Is this like physics?
it's
Because that makes matrices make a lot more sense to me.
We should take physics 1. I don't remember.
we will work more with matrices at a later date.
No.
So we will.
It's only
Yeah.
one day.
Okay.
We have to take it from
Just like melt your.
All right, we are also allowed to multiply by a scalar.
They are matrices. Yeah.
Which one? Because
Or KU, just for Jake. And then if we, this is what I talked about on the previous slide, but if we negate a vector, it's just going to go in the opposite direction. So we can visualize them to be parallel vectors if they are opposites of each other. Right? They'd be parallel. Okay. All right. We are going to talk about a unit vector. Unit is associated with what number? 1. So a unit vector,
One.
what must be 1?
magnitude.
No, just one.
If the magnitude of v is 1, then v ye is a unit vector. It is 7th hour on a Friday of a very long week.
Happy Arts Kids? On the test.
Just today. Just today.
Plus 10%.
I wanted to find one of these things that sound kind of
Just today.
Right now.
Math class is about.
Can't even make a joke for you to laugh at. Okay. This is actually not what I want you to write down. I'm going to change it up a little bit, okay? But the normalization of a vector means we're going to find a unit vector in the same direction as v. Okay? So if we wanted to create a unit vector, we would, I'm going to call it u for unit vector. We would take vector v and we would divide, or we would multiply by the reciprocal of the magnitude. Vector V is 3, 4.
Let's do it.
What's the magnitude?
5.
Picked it specifically for that reason. Okay. So our unit vector,
What's the other one? Something 13.
5, 12, 13. Our unit vector would be 1/5 times the vector 3, 4. So our vector would be 3/5, 4/5. It is in the same direction. They'd be overlapping with each other if we drew them on the same coordinate plane. But this one would have length 1, while this one has length 5. Are you convinced that this would have length 1?
Yeah.
Yeah, we'll take it. No.
25 over 25, right? Okay, that's going to happen every time. As long as you do your mathematics correct.
You're kidding.
So when I get to the test and it doesn't confirm, I'll know to pick up on that.
Okay, let's change your words. I know I should go back and look for my mistake.
I will
Hey, that's
celebrate
not what it
others.
It says when you said I give up, you're supposed
These are
to.
valuable.
What does it say? Number 3.
I give up. I'll use some of these strategies we've learned.
The guess method. This is too hard.
Okay, there is a second way to write vectors. We have a standard unit vector I, horizontally, just 1, 0. This is vector I. Oh, yep, kind of. We have a vertical unit vector, vector J. Okay, so we can either write vectors in component form or we can write them as a linear combination of the unit vectors. So a vector 7, 8 is the same as a vector 7i plus 8j. It's just a different way to represent the same thing. In your book, you will see vectors written both ways. Yes, that is why they chose it.
I feel like I'm This is really vector.
Well, next, after Thanksgiving break, we're going to take our parametric stuff and our vector stuff and smush it together for vector valued functions.
Here we are. I regret that.
All right.
Can't do no.
I knew we were
Of
back
course.
to
Write it down and then we'll talk about it.
Weird.
You know, sometimes when you talk, you sound like that Charlie Brown show. Or wah, 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 wah. Yes.
Is there some branch of mathematics that doesn't do anything but trade? Algebra.
Graph theory.
Graph theory sounds either really bad or really easy.
Bad.
Probably really bad.
Graph theory has nothing to do with trade.
Rhymes with that too.
Because graph theory is like,
Giraffe theory.
Graph.
Giraffe theory.
like
5.
going through vertices and like the number of times you can, like it's,
Draw a giraffe. Please call that.
I mean, it's like stuff like that.
Wait, what?
So is it more like philosophy?
Yes.
Like so it says draw a graph.
Right? Is that graph theory? Yeah, that's graph theory.
Hello.
I should bring like I said, I need to get my notebooks and just bring them to school.
Poor Austin.
Okay. Now, here is our vector. I'm sure he fast forwarded through that chunk. If you didn't.
Also, we're making fun of you.
No, we're not making it.
We're writing it down so you don't know. Probably just wrote something on the board, but I'm not gonna share it.
So here's our horizontal component A, here's our vertical component B. Okay? So this angle right here, that is how we can describe the direction of our vector, right? The 30-degree angle could help us describe the direction of our vector. Now, let's talk about why this is what it is. Okay? How long is the blue vector that I drew? Magnitude of V, right? So, if I want to talk about A right here,
A.
the cosine of our angle is adjacent over hypotenuse. And when we multiply that magnitude over, we get our horizontal component A.
Whoa.
Can we take the last 20 minutes of class outside?
No, I have no way to.
I'll pop open the door.
You can prop open the door, that's fine.
No, it's just really warm out today.
I know, but I have to like stay here for Austin.
Austin.
Sine of theta is opposite over hypotenuse. Move this over. Our vertical component is the magnitude times sine of theta. Okay? Let's put it to good use. Please read.
At 7:27, they throw us out.
What's direction?
So direction is going to be the angle at which we have like that trig angle. Okay? So what is happening?
Everywhere you got it, you got it.
It's like, what is a vector? And then now there's an airplane flying
Oh, it's showing up.
Go, don't look, Jake, don't look.
So we are flying at 500 miles per hour, right?
around. Yeah, I mean, you can't exactly that's 7 miles per hour. That way.
And then we get this 60-degree angle vector, right? Acting on our direction
Why is the plane going?
at 70 miles per. What?
The
What?
picture confused me.
Me too. It's like, I saw the plans in reverse.
Please in reverse.
Okay. What do we need to do with these two vectors?
Combine them.
So it has to go the opposite way.
So we need to add them. We basically need U plus V.
This way.
Okay?
So then it's.
So
Oh, it's just
vector U,
It's going against it.
since it is only going horizontal, then it is the vector 500, 0.
Right.
However, vector V has some direction to it, as well as some magnitude. So what we're going to have to do to get the horizontal component, we're going to have to take 70 times the cosine of 60, and our vertical component would be 70 times the sine of 60. Okay?
We want to use our calculators.
We don't need to. We have 35 and 35 radical 3. Right?
Yeah.
Yeah. Now we will need our calculator. You are right. vector u plus v, well, that would be 535, comma, 35 radical 3. Well, that tells us nothing.
We need a direction.
How do we get direction?
We make it the component form.
Go back to this picture. If we know horizontal component and we know vertical component, how do we get that angle?
Tangent.
Yes.
We're gonna need our direction.
The tangent would be the vertical component divided by the horizontal component. Do you agree? The tangent is opposite over adjacent. Okay, this is like the one time you're going to be in degree mode for my class. Put your calculator in degree mode, unless you want it in radians, and that's fine too. But sometimes it's nice to think about these application problems in terms of degrees. Okay, so if you would like to put your calculator in degree mode, and then find the inverse tangent of that beautiful fraction we have up there. What do you get? Sorry?
6.465.
So that is the direction that the plane is going. 6.465 degrees north of east.
There's no way that's radians, is it?
That's degrees. That's why I put the degree symbol.
Because I don't know how to select that. I'm so sorry.
Oh, I know.
Well, you know, it would help if you use like a real calculator. Now, if I want the ground speed of the plane, what is it asking for about the vector?
Ground speed.
So we got the horizontal.
No. We just scored them squared.
So what are we looking
diagonal
for?
one.
We're looking for the magnitude. Since speed is how we describe the magnitudes of these two vectors, then if we find the magnitude of u plus v, it will give us the speed of the plane.
Okay.
Now, the plane is traveling, like, the plane is set at 500 miles per hour. But if we were watching it with the wind affecting it, we're going to see it go this blue speed. Does that make sense?
Yeah.
Okay. Did you have your hand raised?
Why is it called ground speed?
Because of what I just explained. Do I need to say that again?
Yeah, why is the word ground in there? Why not just speed or air? Or air. Yeah, I like air more.
Because technically 500 is its airspeed, but the wind is affecting it. So if you are on the ground looking up, it's not going that fast. Okay, so let's figure out how fast it is going here. The magnitude of u plus v. Forget.
The pendulum and move goes the same.
Huh? So this plane is going a little bit faster.
We're gonna get him for sure.
So funny story real quick. My boys like to tell us, go faster, go faster. Like, well, we can't go too fast, otherwise the police will come get us a ticket. So my husband got home one day from the grocery store, and my 3-year-old found like the receipt. Daddy, you got a ticket. Daddy, you are speeding. You got a ticket. No. But he thinks he thinks my husband got a ticket, but it was really just a receipt. It was funny to me. It was
I like it. I think it's funny.
I took a stop class this Sunday. Fun fact.
You have to take a stop class?
This Sunday.
Nice.
Yeah, Sunday.
Which one, the 8 hour or 4 hour?
Way too fast.
Oh, Yeah, there's one that
A
R1 and
little,
4R1.
sure.
Let's just say I did call the attorney to see if I could actually take it or not.
So there
Oh
you
my
go.
God. Write this example down. Write this example down. One new thing you learned today.
Don't go too fast.
Receipts are not tickets.
No, this is
Guns are cool.
They are.
Okay. We have a function to execute. I want a unit vector parallel to the graph of f at the point 1, 1. Well, if I'm talking about a vector parallel to the graph at a point, what do you think is important? The derivative. And what's the derivative? What do we need to do with the derivative?
Set it equal to 0.
Nope. Plug in 1. So what is the slope at the coordinate 1, 1? 6. I want a unit vector with that parallel to that.
Let's do it.
Okay. How do we do it?
Do it.
Alright.
So first of all, let's talk about our parallel vector. We need to write a vector that would be parallel to a line with slope 6.
We do the I and J thing.
Sure.
Sweet. Let's do it.
So come up with one for me.
3, 3.
Nope.
6, 6.
Nope.
666.
1, 1.
Why not?
1, 6.
6, 1.
How about 1, 6?
I'll take it.
Because you want rise over run, so the vertical would need to be 6 over the horizontal one. Rise over run.
Oh, I think
I'll take it. I'll take it.
So this is a vector parallel to it. However, we want a unit vector. So what do we need to multiply by?
1, 6, 1.
How do we make a vector have length 1?
Reciprocal
Magnitude.
What would our magnitude be?
Let's see, square root of
square root of 13.
37.
So,
So, 1 square root 37.
I wrote it in component form this time. And guess what? We don't have to rationalize. Now, could I write this as the vector negative 1 over radical 37, comma, negative 6 over radical 37, and it still be parallel? Yes, so there's two different answers here. One that goes positive and it's opposite. Okay. Now, if I ask for a normal vector, perpendicular, so then that's when we would have the 6, 1.
Right.
Okay.
Yes. There we go.
Yeah.